to another video. If you haven't subscribed, please subscribe, do the right thing, and please like the video and share the video with your friends. So in today's lesson, I want us to check the two concepts on your screen, which are elastic and inelastic collision. So we can see that elastic is common in both ways. So I want us to identify the common thing about the two collisions. So in the two collisions, the one thing that you have to know is that the total linear momentum or momentum is conserved. So momentum is conserved in both collisions. All right, so meaning that when we say momentum is conserved, we mean that the sum of P initial must be equal to the sum of the final momentum. All right, so momentum is conserved in both these collisions. All right, so when we talk of elastic collision, that is a point where, or this is a type of collision where, or in which both the kinetic energy and momentum are conserved. So in elastic collision, is not only the momentum which is conserved, but also the kinetic energy. So the kinetic energy is also conserved. By meaning that it's conserved, we know that it must remain the same. So it means that the sum of EK final or EK initial must be equal to the sum of the kinetic energy in the final stage. So this is elastic collision. The momentum and the kinetic energy are both conserved. So if you want to identify whether a collision is elastic, so it means that when you do your calculations, your sum of the kinetic energy before collision must be equal to the sum of your kinetic energy after collision. So if they are equal, then it means that they are indeed conserved, meaning that this is an elastic collision. An example of this collision, we can think of a ball bouncing off a wall. So if you are throwing a ball towards a wall here, and then the ball bounces back and comes to its initial position, then it means that the kinetic energy of the ball is conserved, meaning that the velocity at which the ball was traveling towards the wall is the same as the velocity as which the ball was traveling to you when it comes back. So meaning that if the ball can bounce and come back to its initial position, then that is where we can see that the kinetic energy of that ball is conserved. All right, so that means that collision is elastic collision. Then when we talk of an inelastic collision, it's a type of collision whereby the momentum is conserved, but the kinetic energy is not conserved. So when we say the kinetic energy is not conserved, we mean that, for an example, if we are having a wall here, if we are having our wall here, and then we have a car traveling towards this wall, obviously the car won't bounce back from this wall. The car will crash on this wall, and then that is the case whereby our kinetic energy is no longer conserved, because the car cannot bounce off this wall and go back to its initial position. The car will crash, and when that happens, the kinetic energy will not be conserved and will be transformed into other forms of energy. We know that when a car crashes, we hear a sound, so that energy can transform into heat or sound. So when we say that, when we talk of an inelastic collision, that is the case whereby our EK is not conserved, meaning that the car will have a velocity. Let's say it's traveling at a 10 meter per per second velocity. Then when it crashes the wall, then the car will come to a stop, meaning that our kinetic energy for this car, because kinetic energy only affects objects that are in motion. So if the car now comes to a stop, then our energy can be transformed into what? Into potential energy. All right. So meaning that the car, when it crashes onto the wall, it does not have a velocity anymore. Then when we say that this is not conserved in elastic collision, we mean that our sum of kinetic energy before collision must be greater than our sum of kinetic energy after collision. Because in the initial phase, we know that kinetic energy, or our EK, can be calculated using half mv squared. Then in the initial position, we can see that the car is moving, meaning that it has a velocity v. Then we have a value for our kinetic energy. But in the final position, this was the initial, in the final position, the car will come to a stop, or the wall will bring the car to stop as they crash into each other, and then our velocity for the car will be 0. And then when you substitute 0 here, you can see that it becomes 0 kinetic energy. So that is the case whereby in an elastic collision, the collision or the kinetic energy is not conserved, meaning that the kinetic energy before collision must be greater than the kinetic energy after collision. All right, because the energy can be transformed into other forms of energy like heat or sound or even potential energy. All right, so let's try to look at an example and see how these questions or these two terms can be applied. So here's our example. We're given a car of mass 1600 kg traveling at a speed of 30 meters per second to the left. So we're having a car here. This car has a mass of 1600 kg and it's traveling to the left at a velocity of 30 meters per second. And then it collides head on with a minibus. Then it means this side we're having a minibus. We're having a minibus here. The minibus has a mass of 30,000 kg and it's traveling at 20 meters per second to the right. So it's traveling 20 meters per second to the right. So they crash or they collide head on. So this was the initial stage of the collision. Then the two vehicles now move together as a unit in a straight line after collision. So now the two vehicles, because they collided on head on, then now they were not separated after collision. So this is the final position of this. They are crashed here, and then this is our vehicle. So this is the final stage, meaning that the two, they share what we call, they share a velocity v. So they share a velocity v, which we don't know. But the mass of the two, we know that the mass of this minibus is 30,000, and then plus the mass of this car, which is 1600. All right, so the first question says calculate the velocity of the two vehicles after the collision. So when we see this kind of situation, we know that the total linear momentum is conserved. Then we're going to use the principle of conservation of linear momentum, meaning that the sum of P initial must be equals to the sum of P final. All right, so now we check on our velocities and we have to choose direction. So we have left and right. So we can take our right to be to be positive. So meaning that any motion going to the left is negative. So initially, this is our information. Initially, we had a car, mass of a car, which was 1600 kg, and we have the velocity of that car at initial stage, which was 30 meters per second to the left. So it means it will be negative 30 meters per second because it's going to the left, and then we took right as positive. And then now we also have the mass of the minibus, which is 3000 kg, and then our velocity of that minibus is positive 20 meters per second. Then in the final stage, that is where we had them as one unit. Then it means that the mass of the two is equals to 3000 plus 1600, then which gives us 4600 kg. Then the velocity of the two we don't know, which is the one that we are looking for. Then it means that when we calculate this, the sum of the momentum initially, it means we are going to have m1 v1 plus m2 v2, which is equals to, this side they are sharing a velocity. It means we're having the mass of the minibus plus the mass of the car, then they are sharing the velocity. All right, then when we get here, we know that the mass, our mass one was 1600, and then negative 30, which is our v, plus mass 2, which is 3000, then multiply by 20, which is equals to the two masses, their sum is 4600 multiply by the v final. Then when we do maths, we get negative 48,000 plus 60,000 this side, which is equals to 4600 multiplied by our v final. Then when you punch your calculator, you get that your v final becomes 2,6 meters per second. So meaning that our answer is positive, therefore our velocity is 2,6 meters per second to the right. Then we have calculated our velocity for these two when they are in one unit. All right, then the second question says, do the necessary calculations to show that the collisions were or was inelastic. So to show that a collision is inelastic, we know that the sum of their kinetic energy must not be conserved. All right, so we have to calculate the kinetic energy before collision and then the kinetic energy after collision, and then compare the two. Then the second question, we're going to say for inelastic collision, all right, we have to calculate the sum of the kinetic energy before. All right, so we're going to have half mv squared for car, all right, plus half mv squared for the minibus. All right, so the mass of that car was 1600, then it was traveling at a velocity of 30 meters per second. 30 meters per second, then we square that plus half of that mass, which is 3000, and then we multiply that by the velocity of that, which was 20 meters per second. Then we have 20 here, and then we square that, and then when you punch your calculator, you are going to have 700 120,000 for this one, plus then when we calculate the other one, we get 600,000. Then when you add the two, you will get your answer in scientific form, whereby it's 1,32 multiplied by 10 to the power 6. Then we know that kinetic energy or energy is measured in joules. So this is the kinetic energy before collision. So now we have to calculate the kinetic energy after collision. So our sum of K final must be equals to half mv squared plus half mv squared. So remember, the two were sharing the velocity. So it means we can simplify this equation to be half. We know that it was mass 1 plus mass 2, but they were sharing the velocity. All right. Or even if you can substitute the mass here and the same velocity for every v here, then your answer will be correct. So it means you are having half, then the mass was 1,600 plus 30,000, then our velocity v, the final velocity was 2,6 meters per second. So it means we're going to have 2,6, then we square that, and then when you punch your calculator, you get that it gives you 15,548 joules. All right, so you can see the difference between the two. This one is a very big number, but this one is a small number. So we can conclude that the sum of our kinetic energy is greater than the sum of our kinetic energy in the final position. So therefore this is an elastic collision. So therefore this is an inelastic collision. So meaning that if we calculated the sum before and the sum after, and then we obtain the same answer, we were going to say that the collision is elastic. But now you can see that the initial kinetic energy is greater than the final kinetic energy. Hence our collision now it's an inelastic collision. All right, so this is how you can apply the two concepts when they want calculations. All right, so I think this is the end of this session. Then we will try to do some examples or some previous question papers, so that you get the gist of this concept. So from me to you guys, see you in the next one.